Morning, CascadiaFest. I am really excited to be here. This is my fourth straight CascadiaFest of attendance. I'm finally speaking. Yeah. All right. So today I am here to talk to you about third-party JavaScript or scripting in a third party, because you can't not make a grammar pun here. I'm going to speak in a confessional style and present true tales of horror and hope from writing scripts for other people's pages. My name is Noah Adams. You can find me on Twitter at Noah_Adams. By way of further introduction, I want to sort of present some bona fides to you, why you should trust me when I talk about writing third-party scripts. I'm a software engineer at Mobify, as Florida said. Mobify, we try to present amazing mobile user experiences for our customers. For the last year and a bit, I've been working on analytics and data products, mostly aimed at e-commerce. And these products today serve like billion and change page views a month. I'm going to talk specifically about sort of what I've learned writing a client for this stuff. So first, we'll define some terms. Third-party scripts. What is a third-party script? In this model, the first party is the end user, the person with a browser. The second party is the publisher of a website. And the third party is anybody else involved in delivering that experience. Let's go over some popular examples here. Google Analytics is something a lot of people will be familiar with. That is delivered via third-party scripts. Intercom, which is a popular chat and support widget you'll see in a lot of websites, also a third-party script. Discuss, which is comments for publishers as a service, third-party script. Bazaar Voice provides ratings and reviews for e-commerce sites, third-party script. Most social sharing widgets you'll see on websites, third-party scripts. And of course, everybody's favorite, internet ads. So I went and visited the Intercom homepage to get that screenshot earlier, and went and visited another page 30 seconds later, the Atlantic's trying to get an ad, and it was an Intercom ad. Very fast retargeting. The general class of applications you tend to see as third-party scripts involve data collection, analytics stuff. It's very common. Applications that add functionality to sites, usually in the form of a widget. Things like Intercom. And then integrations with other services. I'd say social sharing falls under that. So in terms of what, if you search for a resource on third-party scripting, you're probably going to run into this book by Ben Vinegar and Anton Kovalyov, both formerly of Discus. It was published in 2013. It has a lot of good tips, but in the intervening 3 years, there's been a lot of change to browser demographics. So a lot of tips and tricks you need to get things done in IE8, you might be less worried about today. So where are we going to go from here in this talk? I want to talk about integrating your third-party script application and delivering it into other people's websites. I want to talk about how you build it. You build it defensively. And then a few notes about gotchas you will have with tools testing and maybe some tips on iteration. So integration and delivery. Integration and delivery for third-party JavaScript is similar to for second-party JavaScript. That is to say, scripts you're writing for sites that are yours. But you sort of have to operate with this in mind. You're also doing this as second-party JavaScript, but here I'm talking about 100 or 1,000 sites. This is the first rule of third-party JavaScript Club: don't break the site. Your integration could be as simple as the humble but noble external script tag. Could be something like a snippet. This is GA's snippet. It's actually doing a few things here in a relatively small amount of code. Or a really popular option these days is the use of a tag manager, especially with marketing departments who don't want to bug IT to get snippets put into their web pages. Tag managers themselves are presented as third-party JavaScript applications. You integrate with the snippet, and then you can sort of add more with checkboxes and stuff. It's pretty meta. So let's talk about how your application should load. You should try and load quickly, but you have the added constraints of not wanting to block the critical rendering path of the site, because it probably is already functional without you in a lot of cases. You also want to avoid blocking the load event. A lot of websites these days, you'll still see scripts waiting for the load event before they'll start doing something with the UI on pages. So the answer to doing these things is often going to be loading asynchronously. Further in how should we load, I will say that most applications will take the approach of loading in phases. They'll first load a small amount of script, which is itself a loader for more scripts, along with some configuration. You can then load more stuff later as you need it, or as you suspect that you're not going to be using up network resources. Also want to not understate this. If you're writing third-party JavaScript, you want to make sure it loads once and then is cached. How do we integrate with our publisher site? So in my experience, we bake configuration into the scripts that we ship. We ship a separate script for every one of our customers that's embedding our stuff. And this is an example of some almost real data for how we configure what's going on there. Other old and, well, popular at the time ways include things like global hooks. So you conventionally say, define a function with this name. We will call it once we are loaded, and then pull in configuration values that you supply. In the case of Google Analytics, I've gone and substituted some variable names in their snippet, shown how it works. They use a thing called a command queue. So the side effect of their snippet is it will define a function that when you pass it arguments, it will just push those arguments onto an array. Later, when the actual Google Analytics library loads, it goes and scoops all of the stuff that's sitting in there in that array and processes it, usually sending events back to their data collection services. The cool thing about this is that you can make your API available before it's even up and working. Another popular way of providing integration is through Markup Conventions. You can store a whole bunch of JSON text hanging off an attribute, or provide other hooks on markup to give semantics to your libraries. On loading without blocking the critical path, a really great way of doing this in modern browsers is to set the async attribute on script elements. This is pretty well supported these days. You'll notice that IE8 is probably the popular thing that is missing, but it's increasingly less and less popular. So if you can avoid supporting IE8 and get away with it, you'll have more fun. If you do need to support it, there's a good amount of literature on async loading patterns for older browsers. It was a big problem a few years ago with lots of solutions. Now, once you've got your little bit of loader script up and running, you're going to want to avoid blocking that load event I talked about earlier. One easy way of doing this is to use Ajax to load the rest of your scripts. Alternatively, you can wait until after the load event to load more scripts of your own. Or if you need to do stuff right now and you're not interested in these techniques, you can just block the load event. Now, let's talk about delivering the actual code and assets that make up your third-party JavaScript application. You'll want to follow sort of regular front-end best practices. You're going to want to minify, ensure that your content is delivered gzipped. You want to shrink down your images, et cetera, all our happy, fun web performance best practices. You're going to want to make sure things are cached. I'm going to make my slides available online. That links to a great article on HTTP caching. Talking about length would be a bad use of my time right now. I will say that you will probably want to make sure your loader has a relatively short cache time. It's sort of the entry point for your code. And if you need to make changes, you want to make sure that people see them quickly. You're going to need to make sure they don't have an old version of your code sitting in their browser cache. Finally, I'd suggest that you might want to leverage CDNs for more or less everything you can. It's less effort on your part keeping servers up to serve static files. And it's going to make things load sooner for end users. If you want to learn more about sort of how involved deploying client-side applications can get, I'd suggest this talk from CascadiaFest last year by Rebecca Murphy, Deploying Client-Side Apps 1,000 at a Time. This is a link if you take a look at my slides. Otherwise, you can search that and find it pretty quick. I'm going to pause briefly and put in a small note about security. This is a big topic. I would be remiss if I didn't mention it, but I also can't explore it that much. But one thing to consider is that if you integrate as a third-party script, your application has become part of the consuming website's attack surface. So if people can do bad things to you, they can do bad things to everybody that uses you. You can do a fair bit in the front end these days. You might provide accidental unauthorized access to data that you're storing in your backend systems. You might introduce a cross-site scripting vector. You might leak credentials. Or if you end up with a particularly bad attack, end up introducing scripts into your customer sites, do things like scrape credit cards. If you're working in e-commerce, this is a big no-no. So now let's talk about building defensively. So I'm going to use an analogy here that building third-party JavaScript applications is like being a guest in someone's home. This means you don't want to break anything, but you might come into a home that's arranged in a way that you're not particularly familiar with. And so you want to make sure that you don't let the site break you. Over the past few years, and at an accelerating rate, the front end of web pages have become complex systems. Last year I saw a talk by Miles Borens, who went on to who described complex systems as being like kinetic sculptures. When one part breaks, the whole system can fall apart. But if we look at what the front end of a lot of websites is like these days, especially if it's a marketing site that's integrated a dozen or so bits of third-party JavaScript, it's a little less uniform and harder to reason about. So much so that in my pitch for this talk, in the abstract, I proposed that one day soon in the future, we might see a combination of third-party scripts evolve an advanced artificial intelligence bent on destroying its creators. I'm not quite sure that will actually happen, but if you're into that kind of thing, the bot startups are hiring. Let's talk about building web UI defensively. I don't have a ton of expertise here, but I have a little bit of experience. One way that people have done this classically is to isolate their content by means of iframes, calls to window.open to open a pop-up window, and maybe web components. I don't know how that's tracking these days for actual third-party scripting implementation. Another common tactic is to add a containing element to the DOM, give it a unique class and/or ID, and then serve the mother of all CSS resets scoped on all children of that element. You are going to have to reset every known property in CSS on every tag. I had a colleague have to do this. He was very upset about having to write this CSS. Also, this is something for true veterans of the specificity wars. You're gonna pound important to everything here. If you want to integrate page styles with your application, that sounds hard, and I'm not going to talk about that. You might be able to avoid some of these complexities with the use of CSS modules. They're doing great things for helping people win specificity wars without trying too hard lately. But now I'm going to move on to talking about JavaScript, because this is the JavaScript in the browser day, after all. So, building JavaScript defensively. Here's the problem posed to developers of third-party JavaScript. You need to work in an environment that combines every active version of every browser with every historical version of every library. This is kind of unfun. In addition to that, you're contending for all of the finite resources that are available in the browser, let's say memory, cookie names and cookie space, local storage names and space, IndexedDB, the global JavaScript namespace, etc. And if you make a mistake, you might break the publisher's site, or you might be letting the publisher's site break you as an application. That's not good. Here's some examples of what can go wrong when you unexpectedly run into other scripts that are doing bad things globally. This is like a thing people are running into pretty commonly, like 2008, 2009, so I'm really going to date myself here. Well, I wasn't even writing JavaScript that much then. But so people are like, I called JSON.stringify on this object with an array in it in one version of the page, and it serializes like this, but in another version of the page serializes like this. Like, what's happening here? Isn't JSON.stringify a browser built in? Like, yes, it is, but that doesn't stop people from monkey patching it. This is a big problem for users or people who ended up in pages that unexpectedly were using the prototype library, which was relatively popular and was very, very aggressive about going and inserting itself into like huge amounts of the DOM API, occasionally with bugs. And people would like, there was a lot of time, effort, and emotional pain spent on getting around these problems. So, like, the fix for that Stack Overflow thing came in prototype 1.7, which shipped in 2010. But as a third-party JavaScript developer, you have to worry about old problems because they are still present on a lot of pages you might get integrated with today. A recent example from my own experience of like the kinds of problems you can run into in other people's pages involved like getting an emergency alarm Slack message about checkout being broken for one of our customers' websites. And like nothing had changed on the website, except we had recently launched a tiny, tiny change to our analytics collection client, which went from using IMG elements to fetch tracking pixels to doing it with Ajax. Like this should not cause a checkout flow to break. It's not obvious how they're connected at all. When we did some analysis on it, we realized that like other bits of code in the page were very ambitiously intercepting Ajax calls. They were picking up our analytics calls, which were returning no data, and they were shoving that no data into the DOM as part of like this checkout process. It was bad. We just like immediately rolled back as a solution. But like later, working on this because we wanted to stop using those IMG elements, we wanted to use XHR, so that we have to operate without trusting the environment we're running in. In this case, this means like looking at window.xml HTTP request and being like, I can't be so sure that you're going to do what I want you to do. So like, what can we do about this kind of thing? This is where I bring in like things I'm mildly ashamed of that are real solutions to real problems. You can find your own fresh copy of the window object. Just make myself a nice little iframe, append to the DOM, because like it doesn't work until you append to the DOM, and then use the XML HTTP request that's hanging off of that. This falls into a class of like really common third-party JavaScript techniques I have called #stupid iframe tricks. I think there's at least a good conference talk on this topic, if not its own conference. There's lots of fun things you can do with iframes. So another classic problem in third-party scripting is making cross-domain requests. Especially if you're doing data collection, you're probably going to want to deliver data somewhere. Or if you're doing something more ambitious like Discus, you need to like be both fetching and delivering data to some API somewhere that is not on the domain of the publisher site. These days, this actually like looks pretty easy. This is the support for cross-origin resource sharing in browsers. You're pretty good unless you're Opera Mini. Like today, you can mostly just get away with CORS. In the past, that was less true. I've definitely had to worry about like making things work on IE7. That's as bad as it's gotten for me. But there's a library by Anton Kovalyov, one of the authors of third-party JavaScript, called EasyXDM, which presents a means of doing messaging to other domains portably and reliably, even in older browsers, but maybe a little slowly. To close out, I would like to talk about tools testing and iteration on your third-party JavaScript application. So that bit I just talked about in terms of building defensively and the constraints it imposes, this environment of other people's pages puts those same demands on the tools and the dependencies that you integrate into your code. So again, don't break the site. I'm going to talk really quickly about modules and build systems. So one day, I got a Slack message from our CTO. He had like a little screenshot of like this error on the console. The fact that it's obscured doesn't make much of a difference. All you need to know is it's an error, it's quoting some code, and that code is my code, and that shouldn't happen. What's interesting about this error is it's coming from require.js. What's interesting about that is I am not using require.js for this code, but I am getting errors from require.js about it. And not all the time, only like 1 out of 10 reloads of this page does this error show up. But the customer, who is based in Brazil, gets it all the time. So like, this is a real poser. Like, what am I gonna do about this? Turns out, the problem was I was using libraries defined with universal module definition syntax. This is a technique that came out a few years ago for delivering libraries in a way where they can be built with both Browserify tooling and require.js, RJS, AMD, etc. I'm not quite sure how Webpack plays with this stuff today. We're still using Browserify on the particular bit of code where that was included, but like it's interesting to note that like this like linking process here, where we're making our module available to other code, is dynamic. It's done with if statements, and this dynamism is what's shooting us in the foot here. So on that page where we were getting a require.js error, they are using require.js. And if require.js happens to load before our script does, they're both loading asynchronously, some of the modules in my built Browserify bundle are going to like say, hey, I see a require, or rather I see a define on the window object. I'm going to use that to define myself. And then your code breaks. So like, know and understand your build tools. Like, when you're loading things asynchronously and you have problems with how things are like put together, you can have weirdo race conditions that affect whether your code can even like start running, which is not a problem I thought I would have to deal with. A couple of really, really quick notes on testing. Unit tests, please write them. You'll thank yourself. But in a way that is different to how at least I have approached writing second-party JavaScript, you're going to want to write integration tests that run against your built files if you were using a build system of modules. And you're going to want to do things like test for global variable leaks, both from your own code and potentially from your build tools. I had a fun experience of tweaking a Browserify option to like alias a module, and suddenly rather than my module loading as a closure with its own require function defined inside it, it tried to define require globally. And if you end up on a page that also wants to define a function named require, you're going to be fighting for that name, and that's bad. You're going to break the site. Finally, when you're building those integration tests, you want to run them against lots of browsers. It's probably beyond your ability to actually assemble all of those browsers under one roof to do the testing yourself. Luckily, there are vendors here to help you, and they're willing to like help you out for free if you're doing open source stuff. I found Sauce Labs really indispensable, but BrowserStack and TestLing are also going to help you out here in terms of getting your tests running everywhere. All right. The last suggestion I'm going to leave people with, if they're interested in developing third-party JS, to help you do iteration, you're going to want to build a way to load new versions of your script on current running production versions of your customers' pages so that you can do manual testing before doing releases. If you are low on resources or a lone developer, you can do this with proxy tools like Charles or Fiddler. Or you might decide that you want to build it in as part of your loading script. So what we've covered today, we talked about integration and delivery of third-party scripts, building third-party scripts defensively, and then how we use tools, testing, and iteration when we're building third-party scripts. Final notes. Writing third-party JS is fraught with peril, clearly. You will get a couple of gray hairs out of it if you're targeting 1 billion page views a month. But it's also a very, very powerful medium of expression in software. Like, you can deliver new features across like hundreds of sites that are not your own, basically as fast as you can develop and test them. And that's really awesome and really powerful. So I will say thanks. My slides are available at that bit.ly URL, bit.ly/thirdpartyjs. I am at Noah_Adams. You can find me on GitHub as Noah Adams. That's about it for me. Thanks.
Woo! Hey, give it up for Noah.